All right, here we go. So today, what we're going to be talking about, this is a reminder. So yesterday we started with GimKit, right? And we did a GimKit that dealt with, this is a review for you guys. All right, so everybody, you guys have already gone through this, but after yesterday's GimKit, I noticed that probably we needed to chit chat about this really fast. So we're going to really quick spend about 10 minutes on how to find the area of parallelograms and triangles. All right, so it is going to be super duper duper fast. Okay, so first of all, here's my first question that I want to ask to you guys. What is a parallelogram? So hold on, don't say anything. All right, I'm going to pause and then I'm going to ask you guys. So what is a parallelogram? So on the video, please press pause. So we had a couple of really good answers, but the best one that I heard was that it looks like this. Two sets of parallel sides. Two sets of parallel sides. There's more. A parallelogram also has opposite. I almost forgot how to spell that.
Supposed to be writing this down.
Nope, not yet. Opposite angles are called congruent. All right. So opposite angles are also congruent. I'm going to show you what that means right now. So here are 4 different parallelograms. Okay. These are 4 different things of parallelograms. And if you look at this, so parallel, whoa, I don't want that big. Let's try that again. Okay, so this side is parallel to this side, which means they're never, ever gonna touch. All right, and then these 2 sides are parallel, which means those 2 sides will never, ever intersect. Okay, same with this, parallel, 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 parallel. Parallel, parallel. Now, the other part that we said is opposite angles are congruent. So this angle right up here is 90 degrees. Well, so is this one. This side angle right here is 90 degrees, and so is this one. Look at this one. This angle right here is going to be the same as this one, and this one right here is going to be the same as that one, right? Opposite angles are congruent, okay? So, any questions on about what a parallelogram is? Nope, we're good? Okay, so on your papers that you guys just got, can you guys please write down a parallelogram has 2 sets of parallel sides and opposite angles are congruent. Write that down, please. All right, so if you take a look at this guy right here. Okay, does anybody know what that's called? It's a what?
Trapezoid.
It's a trapezoid. Is this a parallelogram?
No.
Yes or no?
No.
Why?
Because it,
Okay, all right. Why, Lincoln?
because it doesn't have 2 parallel sides.
Right. It doesn't have 2 sets of parallel sides, right? So these guys are parallel, but these guys, if you were to continue these out, these would end up crossing way up there. So it is a quadrilateral, but it is not a parallelogram. Okay. Now that we know that, okay, if we want to find the area of the parallelogram, and I know you guys already know this, but I just want to show this to you. If I asked you to find the area of this, what you could do is if we put this on graph paper, we would just count all of the squares on the inside, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 41, 42, 43, 50, 60. So there are 60 squares inside of there, but how many people actually do that? Nobody, right? All right. Maybe when you guys were in 3rd grade, 2nd grade, but not now. What could we do that would be way easier to find the area of this? So we're going to count this side, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We're going to count this side, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, sorry. All right. And then all we need to do is multiply those two sides together, right? Because what's 5 times 12? All right. And that's exactly what we got. Units squared. Okay. Because these are not labeled, they're just units. All right. So, all right. But what if you get a parallelogram that looks like this? And this is what we had on the GIMP kit yesterday that a lot of people got super confused. So if we were to count these out, this is 1 whole, 2, 3, 4, 5, 6, 7. Uh-oh. And it's a little over half, but I don't know what to do with it. So I caramba. All right. So what do you think I would do?
Still count it as a whole. Right?
Not quite.
Or do you like you get to count and you count that as a whole?
You count that as a whole. I like your thinking. All right. Here's what you could look at this. If we were to chop
I know what to do.
this section off, we could put it on this section right here. And now look at that now forms a rectangle, doesn't it?
Oh, yeah.
So we could chop this part off. We could fill it in over here. And now what is my base here? How many is that?
4, 5, 6, 7, 8, 9.
8, right? I think 1, 2, 3, 4, 5, 6, 7, 8, because I chopped that piece off. And then what is my height?
6,
1, 2, 3, 4, 5, 6,
7.
7, right? And so I could do that, right? Here, but here's the thing. Not many of you guys are going to chop off that side of it and add it onto the other side. You're not going to do that. So what you're zoning, don't zone, this is a no zone zone. But look at, I want you guys to see this. Where did my base of this meet my height? What is the angle that those two met? What's the angle? It's a 90-degree angle. Very important. So if you look at this, what we could do is this. I could just put this line right here in. So my base is still here. And my height is the distance from this base to that base, which was 7. And so all I'm going to do now is 8 times 7 is 56 units squared, because it's area. All right, so can you guys write this down? This is the formula to find the area of any parallelogram. It's length times width, which is L times W, or it's base times height, which is BH. Okay, so either of those will give you the is the formula to find the area of any parallelogram that you might see out in the world. Okay. So I'm going to, you guys need to pause this to write this down. All right. So now, if you look at this problem, can you guys on your paper, can you guys find the area of this parallelogram? Okay. What is the area of this parallelogram? Okay. Notice that it is labeled in inches. So awesome job. A lot of you guys use the formula. Area equals length times width. So area equals 12 inches times 8 inches. So 12 times 8 is 96 inches squared. So that's where that square comes from.
Is it also cube?
No, only volume. That's volume.
Okay,
Yep.
cube 3.
Yep. Yep. Now, I did see a really cool way of multiplying this, just to let you guys know. I saw somebody break this into 10 and 2. And so this was 80 and this was 16, and they just added those together. Nice. Those are just, that's distributed property in action. All right, good job, good job, good job. All right, now, I'm just making sure I'm recording. All right, now that we know about parallelograms, let's take a peek at triangles, because this is where we had issues yesterday. Okay, so what can you guys tell me right now about the relationship between a triangle and the rectangle? So what's the relationship between the triangle and the rectangle? So what these guys came up with is this. first of all, they both notice that there is a length, or AKA base, and there is a height, which always meet at that 90-degree angle. But what they noticed is that this triangle is only half of what the rectangle is. It's only half of that. So with that being said, here is your formula to find the area of any triangle. It's base times height divided by 2, or it's 1/2 base times height. Please write that down on your papers, please. Okay, so now that we have that, first of all, with triangles, and again, this is what I saw in GimKit yesterday, is we were having a hard time because when you have a triangle, you have 3 sides, and then you have something else that they label. All right, so you have to be able to figure out which one is the base and which one is the height. So in order to figure that out, you're always going to look for the base meets the height at the 90-degree angle. So therefore, see how this line meets this line at the 90-degree angle? That means you don't need those at all to find area. So all you're going to do is you're going to go 10 times 8 divided by 2, or 1/2 times 10 times 8. So 10 times 8 is 80. 80 divided by 2 is 40. And now we label it inches squared. Or if you do this, what's half of 10? 5. 5 times 8 is also 40. And then we label it inches squared. Okay. All right, look at this one. All right, this one is super awesome because of the fact that it gives us our base and our height, because it meets right there at the 90-degree angle. So what is our base here? Which one's our base?
16.
Good. Our 16 is our base. Therefore, is 20 our height or 18 our height?
18.
Good. Can you guys please write this problem down and solve it? All right, so what did you guys find the area to be? What was it? Say it out loud. Go.
144.
Wait, what?
One.
What?
Well, here we go. Here we go. Let's find out. Ready? Stop. 5, 4, 3, 2, 1. So area equals base times height divided by 2, right? So if our base is 16 and our height is 18, we're going to multiply those, or we're going to multiply those together and then divide that by 2. All right. So 16 times 18 is how much? 288. So 288 divided by 2 is 144 centimeters squared. Or what you could do is you could go half of 16, which is 8, and 8 times 18 is 144. And don't forget, when you label it, it's centimeters squared. Got it? Okay. All right.